Hello everyone. Today I would like to present the paper. The title is Contents by Collaborative Filtering Using Word Embedding, a case study on movie recommendations. The authors are Lương Vương Nguyễn, Chí Hải Nguyễn and Jason Ji Chung. My present content includes 5 sessions. The session 1 is Introduction. The session 2 is Work Embedding by CF methods. The session 3 is Measuring Similarity. The session 4 is Experiments, and the conclusion is the final session. The introduction. The lack of social rating will reduce effectively modeling user references and finding trustworthy similar user in the collaborative filtering by recommendation system, also known as cosine problem. And as you know, the traditional CF use information filtering techniques to recommend items based on history. So the CF algorithm usually rates better performance on prediction if there are many interactions between user and item. Otherwise, the CF could not have a good performance since it does not have enough user information. So to solve this problem and improve the efficiency to recommend the system, we propose the new contents by CF approach using the word embedding. In this paper, we further improve the performance of contents by filtering approach by proposing a new similarity measures between items to solve the sparsity and cosine problem. In our approach, the movie recommendation system is applied. In particular, the features such as title, genre, director, actor, and plot of the movie are attractive. Clearly, the future information is more reliable than the user rating, since they provide by movie experts, for example, the director or the producer. And especially, the word embedding has been proven to be effective in terms of textual representation compared to conventional models such as TF-IDF, vector or best of words model. Therefore, we construct the semantic vector for the plot feature of movies by applying the vectorized embedding model. Then the similarity of the movie is calculated by short cosine measures by on vectorized feature. The feature information is available when movie content is created. Therefore, the system always has the feature information even with newly added movies. As a result, the system can be avoid the cosine problem. Going to the work embeddings by CF methods session, we are following the key assumption. The attractive feature from the movie can represent the movie. The history of the activity by the user, for example, movie have seen or movie similarity, can imply user preference. Therefore, the similarity measurement between attractive feature from movie can reveal the similarity between movie. For example, given the movie MI and MZ are similarity movie, the formulation for measuring the similarities by on feature attractives were describable as follows. Sim MI MZ equal a set of feature TIZ, ZIZ, DIZ, AIZ, and PIZ, which are represent the similarity of features such as title, genre, director, actor, and plot of the movie MI and movie MZ, respectively. To construct the semantic vector for each plot of the movie, we decide to use the work-to-vec embedding model. The work-to-vec can use either of two model architecture to generate a distributed representation of words, continuous base of word or continuous skip prime. In particular, we convert each word into a probability vector based on the pre-trained model provided by Google. This pre-trained model includes work vector for over 3 million words and phrases that have changed from approximately 100 billion words from a large data collection of Google News, and length of each word vector constant 300 features. And to implement the work-to-vec embedding model, we use the GainSim, which is an open source library for unsupervised topic modeling and natural language processing. The process of the implementing as follows. The first step is creating a vector for every word in the plot content of the movie, and the second step is to construct an integrated vector that will represent the whole set of the plot contents of the movie. In this work, we use the average value of the vector to obtain the final vector of the plot contents. And finally, every plot contents of the movie has been converted to a semantic vector. Comparing to the conventional TF-IDF vector or base of word model, the vector have the better representative for the plot content of movie in our database. For measuring the similarity, we separate the feature into groups. The first group is title, genre, actor, director, and the second group include plot. So for the first group, we use the Jaccard coefficient to measuring the similarity and the cosine similarity for measuring the second group. So the Jaccard coefficient, which is the common index for binary variable, is defined as the quotient between the intersection and the unions of the pairwise compared variable among two objects. For example, look at the equation. The F(i) and Fz denote the feature key. The feature key includes the title, genre, director, and actor of the movie I and movie Z. The cosine similarity we use to measuring the plot of the movie. Clearly, in the vector space model, the traditional cosine measure is commonly used to determine the similarity between two objects represented as a vector. Given two vector x and y, the cosine similarity measure between them is calculated by equation 3. And back to our work. Considering the case of the plot content presented, the final output vector after using work-to-vec is used to measure the similarity between movies. The vector BA and BB are the outputs of the word embedding model from plot content of the movie A and movie B. So the formulation for measuring the similarity between plot content of movie A and movie B are describable as equation 4. We are going to the experiment session. we want to talk about our data set. Our data set were collected from our OMS platform, crowdsourcing platform. We are collected more 14,000 popular movie from 1990 to 2019, includes 9 young, 3,439 director and 8,057 actor. For collecting the movie information, we use the Open Movie Database API, and when we obtain on the movie information that's provide for the experiments. Our statistical of the movie dataset shown in the table. The most important step in collaborative filtering system is to generate the predictions. When we obtain the set of similar items by on movie similarity, the next step is to look into the active user and use the technique to obtain the prediction. In this step, we make use of the outputs of the previous step in order to predict the similarity score for a pair of user U and movie I. So in the algorithm, our algorithm movie similarity, we have a 3 steps. The first step is we represent the user U, and the second step we represent the item I, and finally we predict the similarity score for the pair of user U and movie I by on the relevance between the user and the item. The evaluations, the similarities movie for a typical user are considered to be those that have a similarity score greater than 0.5, and therefore in this way, every similarity score greater than 0.5, the corresponding movie were labeled by 1, otherwise it were labeled by 0. We randomly selected 20 users. The proposed prediction algorithm will execute for 100 different movies. In each case, based on the predicted similarity score, the label 0 and 1 were assigned. The final recommendation list consists of the set of the movie that's labeled 1. So we use the evaluation matrix includes accuracy, precision, recall, and F1. The accuracy is the proportion of correctly predicted label over the total number of labels. For example, in this work, 100. Precision is the fraction of actual similarities movie among the list of recommendation movies. The recall is the fraction of the similarities movie that recommended over the total number of the similarity movies. The F1 score is combination of precision and recall criteria. The experimental results. We compare our proposed methods with 2 bylines, the car nearest neighbor and the correlations by item similarity. As you see in the table experimental results, our proposed methods achieve the highest improvements in comparing with KNN and CIS. For conclusions, we are propose the new content-based methods to improve the collaborative filtering by using the work embedding. Our methods include 2 clear steps to deploy the measurements. The first step is to transform an attractive feature from the movie to the vector. Basically, we apply the vectorized embedding model that constructs semantic vector for each plot contents of movie. In the second step, we did the measure for each feature by using vector sort cosines by similarity. Then we obtain the set of movie similarity. For the future work, we intend to collect more data from the open API and the feedback from the user, and we will do the evaluation with more other metrics, also more other comparing with more other methods. So thank you for listening my presentation.